Well, we've learned a lot of things about friction. We've learned that the friction is proportional to the normal force. We've learned that there's a constant called the coefficient of friction. We've learned about static friction and kinetic friction. And now we need to try some problems. So make sure you have a calculator and a pen, and it's time to look at some problems. So we read the problem. A 7.6 kilogram object is resting on a horizontal surface. What is the normal force acting on the object? And then we read a 2 kilogram object is placed on top of the 7.6 kilogram object. What is the normal force now? Well, the weight acts down, and the normal force is reacting to the weight pushing down. And in this particular case, the normal force is just equal to the weight. So all we really have to do is calculate the weight of this object. So we write W equals mg, and the m is given as 7.6 kilograms. It's there. And g, we can write 9.8 meters per second squared. And remember, a kilogram meters per second squared is a newton. And when we calculate it, we find 74.48 and that's newtons, which we will, everything is two significant figures, and we just simply write the answer as 74 newtons. And there's the normal reacting force, the normal reaction force that we wanted to find. So, now we go to part 2 of the problem. And it says, a 2 kilogram object is placed on top. Well, there it is, placed on top. Now, all we've really done is increase the weight. And so the top one has a mass of 2 kilograms. The lower one is still 7.6 kilograms. And we need to find the total weight. The weight acts down, and the reaction normal force simply pushes back up, and it equals the weight again. But this time, the weight will be m, which is the total of the two masses, 9.6. And so we'll write 9.6 kilograms, the total of the two, and we multiply by 9.8 meters per second squared. And once again, we just calculate it, and we find the answer to be, when we round it off to 2 sig figs, 94 newtons. You should try the problem yourself now.